So good morning. In today's class we'll discuss about what's meant by proof of elapsed time, POET in blockchain. Actually it's a consensus algorithm. So we've been learning about proof of work, we've been learning about proof of stake. So similar to that, this is actually a consensus algorithm, and the aim of this algorithm is it prevents high resource utilization and prevents high energy consumption. So the basic logic is it implements a fair lottery system such that the whole process is kept more efficient. So what is this proof of elapsed time? It's actually a consensus mechanism that was developed and invented in the year 2016 by Intel Corporation, and it's actually considered to be the fairest blockchain consensus algorithm. So we've heard about permissioned blockchain and permissionless blockchain. So let us assume an industry is maintaining its own blockchain for its operations. So we call it as a permissioned blockchain. So this POET enables a permission blockchain network to determine who will create the next block. Actually Intel, it worked with other organizations, a Linux project and IBM, and it sponsored a project called as Hyperledger Sawtooth. So this is actually open source project which uses this POET consensus mechanism. So what is the basic feature and how does it work? So the basic objective is it will reduce the energy consumption which is associated with the proof of works mining process, and the whole mechanism is based on BFT, Byzantine fault tolerance. So we'll try to learn 4 important issues related to this algorithm. This algorithm depends totally on a trusted hardware. It's called as SGX, or secure time measurement. Next is it is designed to be resistant to various type of attacks. So these type of attacks like Sybil attack cannot happen if the network uses POET. Compared to this proof of work, it can handle large number of transactions and participants also. And the most and the best important thing about POET is like all nodes will have an equal opportunity to propose new blocks. So we'll see how it happens. So first we'll analyze the basic features of proof of elapsed time. Actually it helps in minimizing the energy usage by avoiding all those complex calculations which was happening in proof of work. And how is it done? So in spite of solving computationally tough puzzles like proof of work, all that is done is we are going to, the core part of the algorithm is to try to look into the node which has waited for a longer time, that's all. So whichever node has waited for a longer time, that is given a chance to propose a new block. So the consensus is achieved through waiting periods. The second one is it can handle a large number of transactions and participants. So if you want to implement a blockchain which will be scalable in near future, POET could be a best choice. The third one is it supports a high transaction throughput compared to a proof of work based system. So logically speaking, efficient resource utilization. The fourth one is every node will have an equal chance, because we saw like in proof of elapsed time, it just tries to find out which node was waiting for a longer time. So the selection is based on randomly determined waiting periods. The fifth feature is randomized selection. So as it was mentioned earlier, this is supposed to be the most fairly operating algorithm. The sixth one is about low infrastructure cost, because you don't need high performance computing hardware like proof of work, so automatically your cost gets reduced. So what are the 3 factors that need to be in favor of POET to work? Number 1, it relies on an exclusive hardware, Intel's SGX software guard extension, or similar trusted extension environments, TEs. Why should it need this? Because it ensures secure and accurate measurement of elapsed time. Without a secure hardware, you cannot say like it is very fair, it is very trustworthy. So this is needed, secure and trusted hardware. Next one is network participation and fairness. So in case if you want this consensus algorithm to work on a fair basis, you should have a very large set of nodes, diverse set of nodes. All of them should participate, and everyone should have different, they should all accept that yes, we will adhere to the protocol. In case only few nodes are accepting and few nodes are not accepting, again this consensus mechanism cannot be accepted. It will become unfair. Then finally it is almost like centralization. So that also is not fair. The third one is time measurement and robust randomization. So this whole algorithm or the whole consensus protocol relies on generation of random wait time. For what? So that to ensure that every node gets an equal chance of proposing a new block. So this is the third feature. So all these three factors should be in favor. Only if these three are favor, POIT will work properly. One is you need the hardware, then you need a very big network, and all the nodes in the network should adhere to the protocol. And next one is relying on a generation of random wait times. Fine. How does it work? So first all the nodes will have to set up a hardware. Then every node will generate a random wait time using that secure hardware. That hardware will ensure that the wait time cannot be predicted or it cannot be altered by the node. So there comes the fairness. Third one is waiting period. So every node will wait for a duration of its randomly determined period before it starts proposing a new block. The fourth one is a block proposal. After it just waits for some period, right? And after the waiting period elapses, the node that has waited the longest will be eligible to propose the next block. And that block will have to send its valid transaction to all the other neighboring blocks. Next comes validation. So in case if a block is proposed, all the other nodes in the network will volunteer and they will start validating the worthiness of the proposed block. So what will it verify? It will verify whether the proposer's wait time was randomly generated and not manipulated. Fine. In case that block's proposal is valid and it meets the network's protocol, that consensus rule, then what happens? Automatically that block will be added into the blockchain. So that is called as consensus achievement. So if you want to implement this, you need an architecture, right? So what is this POIT protocol? As I said, it needs a secure hardware. Yes, Intel's SGX. So what does this do? It will provide a secure execution environment to generate and enforce random wait times. That's all. And these wait times should not be seen or tampered by anyone. Fine. Second one is there's a software component, which means a POIT algorithm, which will manage how the nodes are interacting with each other, how the consensus is achieved. The third one is the different nodes which are participating, which is responsible for the consensus process. The fourth one is communication layer. So a block will have to propose that this is a newly identified block and others accept. So how does that proposing of that block happens unless and until we don't have a communication layer, for which it needs a network layer, right? The basic infrastructure, and the security layer which verifies integrity and security of the process. Moving on to the benefits, as we saw, very less power consumption, less resource sensitive also, high transaction rate. This POET can go up to million transactions per second. Everyone gets an equal opportunity, and this basically works in a permissioned blockchain. The same could even go to identify the limitations. You want a specialized hardware. In case if there is no compatibility among the nodes or with the tools, it's an issue. Compared to proof of work, this proof of stake POET is not much acceptable and not widely adopted. Next is the participants should trust the hardware vendors so that they don't compromise on anything. And if at all that there's something happening, if there's any vulnerability, then the whole security and integrity of this whole algorithm cannot be accepted. As we are going to use a specific hardware for this, of course, it's going to be a little bit costly. So what are the use cases where all can use this? So it is beneficial for IoT applications. This POET can be used to ensure secure and fair consensus among entities which will manage digital identity, like the health schemes that are provided by the central government. For senior citizens. The next is tokenization and digital assets. So you can manage digital currency, and it is suitable for managing tokenized assets. Next is regulated industries. So in case if you got complaints with energy usage and operational transparency, then we can say that POET requires a comparatively less amount of energy. Moving on to enterprise environments, it is suitable for enterprise environments where fairness is very important, and if at all you have the provision to use the trusted hardware. So to conclude, this POET is a highly efficient and it works with SGX. And there could be a lot of applications which can be thought of when you use this SGX and use a POET consensus model. So that's about proof of elapsed time. Thank you.